some terminology. This is something that's really, really important that you get, and it's the idea of the population and the sample. Now, in the thing that I'm doing at the moment, the population is all of you in this room. So, in fact, I could find out how many hours you pretend or report that you've done in Blackboard for the whole population, because it's not going to cost me a lot. I just have to collect up the numbers, add them all up and so on, and I get the answer. But mostly a population is so big that we can't actually find out about things. So in terms of statistics, a population is a complete set of people or things. Now, parameters are things like the mean or proportion. And if you were here, if you remember the earlier stuff, we talked about that the mean was a way of representing a whole set of data. So with these five, with this class, I could say list all of the numbers, but if I just want to give one number, I give the mean. Okay, a sample is a subset of the population, and the actual measurements constitute the raw data. So what we've got here, this is called raw data. The sample statistics are the characteristics, which is what we found. We found the mean. And one person or thing is called one observation. So all of those pink words there, you need to know what they mean. I first made this up for a group of physios who specialise in hand injuries that had a conference down in Queenstown. And I had to give this presentation, this particular bit I'm doing now. My sister very kindly asked me to be a keynote speaker there to talk to them about statistics. Okay, so we're talking about physiotherapists here. You can imagine how gripping they found statistics. But not only that, I had to do it at 9 a.m. on the Sunday morning after they'd had the party the night before. And it was compulsory attendance. So I did wonder whether my sister actually liked me or not, or if it was just some mean way to get back at me for all the years of whatever I did to her. Kept my room untidy, really. That's the main thing. Anyway, so this is something I made up to try and get across the idea of sampling. So if we look here, we've got a picture of a whole lot of people here. I think there's 200 of them, or 200 families. And it represents number of live births per woman. So you see you've got one of the black ones there. This is a person who's had no live children. That sounds terrible. Has had no children. Okay, and then this one here, this person has one child, and then the green one's got quite a few, and the yellows have got one, but whatever. So it's different people. So that's your population, and we say we can't find out. Like, we couldn't go through the whole of New Zealand and find out, ask each woman, how many babies have you had? Because not only is it going to take a really long time, but the other thing is quite often they're not going to tell you the truth anyway, because there might be one that they didn't tell their husband about and things like this. Okay, so we've got to the sampling here. So we go along and we take a sample instead. And so if you can see, there's little red bits around some of them. So randomly, and I'm going to talk in a minute about how to do sampling. So we take this sample, which is hopefully representative of the population. So that's the sample there. So it's just some, and we've just gone, how many babies, whatever. And so then we turn it into like a pictogram or something like that. And then we turn it into a graph. And I know it says fertility. It's meant to say fertility, but it happened so long ago, this little graph, that I can't actually find the file, and so you just have to put up with fertility. Okay, so you've all seen histograms. Actually, this is a frequency bar chart, so it's saying that there were 4 people in the sample who had no babies, there were 11 that had 1 baby, and so on. And then this bit here should be familiar to you, I think. Well, it will be. It will be alarmingly familiar to you by the end of Module 5 and 6. This is the output from Excel to descriptive statistics. So it's taken that information from the previous data there from that sample, and it's found the mean, which is 1.96667, the standard error, which is not the same as the standard deviation. And so these, okay, are they population parameters or sample statistics? Now here's something really handy. Look, population parameter both start with a P, sample and statistic both start with an S. That's how you remember that those words go together. Okay, so is this thing I've got here a sample or a population? It's a sample. So therefore these are sample statistics. They are not population parameters. Now, somewhere out in the universe, there is a number that is the average number of live births per woman in New Zealand at a particular point in time. It exists. There is no way on earth we're ever going to find it out exactly, because by the time we've counted, it's a different time anyway. And so this thing here, this 1.96, is an estimate of what that population parameter is. So this is I've got here still. So the point is, this is the essence. We want to find out something about the population. We can't measure the entire population. Now, if we can measure the entire population, we don't need to do all of this inferential statistics. We just measure it and we say, this is what it is. Like I can actually go to Blackboard and tell you exactly how many hours on average students have spent in the last week. It will tell me, and it's not very much. But we're just assuming in this class that we couldn't do that. So we can't measure the entire population, so we take a sample. And you have been part of samples. Okay, say you make a batch of cupcakes. Okay, how do you know whether they've turned out all right? How do you know? You try one. You open it up, you look inside, you eat it, you go, yum, that was very nice cupcake. From this, I can say that the rest of the cupcakes are probably going to be fine. Okay, would you expect that if you have one cupcake that's really yummy that the rest of them are going to be disgusting? No. There might be one that was sort of from the bottom of the bowl that didn't get much chocolate or raspberries in it, because I make chocolate raspberry cupcakes. And so it might not be quite as good as the others. And if that was the one you sampled, you might go, that wasn't very good, I better try another one just to make sure the rest of them are okay. But if you eat the whole lot, you actually don't have the population anymore, it's just gone. Which may be the point of the whole exercise, but we're assuming that it's not. So we actually sample all the time. When we look outside and say, I wonder what the weather's going to be like today, we take a sample of what is it like now. It's grey and raining. Okay, from this I will infer that possibly throughout the rest of the day it may be grey and raining. And it may be grey and raining over the whole of Christchurch, not just where I am. So I've taken a sample of the temperature and weather here, and from that I will infer about what's going to happen the rest of the day wherever I am. So sampling is actually a natural part of our lives. And so when we do it officially in statistics, we use our knowledge of probability to estimate how likely we want to be to draw a correct conclusion. Because any time we do sampling, we could get it wrong. It could be when I took the first 5 that I just happened to get the 5 laziest people in the class or the 5 most hard-working people in the class. That is always the chance. Or the 5 most prepared people so they didn't need to work this week. Okay, so we work out how likely we are to draw the correct conclusion. Now, if we want to be really, really certain, what we do is we just make a really wide band of information which is so vague that we can be certain that we're right. So I could say, I know for certain that the number of hours on average spent by this class in last week lies between 0 and 200 hours. Okay? And I can be absolutely certain that that will contain the mean. But it is a particularly useless piece of information. So you've got your trade-off between usefulness and certainty. So we take the information of the sample to make inference about the population. Now, depending on the nature of the sample, we may or may not be correct. And the absolute key part is that we don't know. We never know. Well, we could later on if something else happens, like we could say, oh, well, the economy isn't going to change, and then it does. But at that point, we infer, we say we are 95% sure that this is the case, but there is always a 5% chance that we're wrong. And that is the key to confidence intervals that we'll be talking about tomorrow.